Fermions are particles whose spin angular momentum is a half integer. Spin corresponds to the angular momentum of rotation. When the spin is in the same, or opposite, direction as the velocity, it is called right-handed or left-handed. Assuming an observer A observes the particle's velocity and spin as v and left-handed, respectively. Suppose that this particle is observed by an observer B who is moving at a speed v' in the direction of the particle's velocity relative to A. If the mass of the particle is 0, the velocity of the particle is the speed of light and B is greater than v', B also observes the left-handed particle. The situation changes if the particle's mass is not 0. Since the speed of particles is slower than the speed of light, the speed of B can be faster than the speed of the particle. In this case, v' is greater than v, and the particle is moving in the opposite direction and appears to be right-handed for B. The mass is responsible for the mixing of particles that are left-handed and right-handed. A Dirac particle is characterized by the independence of the left-handed and right-handed particles. Dirac particles have 4 degrees of freedom: left-handed and right-handed, particles and antiparticles. On the other hand, if the particle and antiparticle are identical, it is called the Majorana particle, which has only 2 degrees of freedom, right-handed and left-handed. The law of conservation of charge prevents the particle and antiparticle from being the same if a particle has a charge, such as an electron. In contrast, neutrinos, which are neutral particles, can also be Majorana particles. The Lagrangian density that leads to the Dirac equation is shown. In field theory, psi annihilates a particle and psi bar generates a particle in the mass term. For example, the first term eliminates left-handed particles and generates right-handed particles. A Dirac mass term refers to the case where psi L and psi R are independent. When the charge conjugate of psi L is used instead of psi R, it is referred to as a Majorana mass term. The interaction of the mass term results in either annihilation or generation of 2 left-handed particles. In other words, it serves to change the number of particles by 2.